In this video, we're going to look at the triangle area formula. More importantly, we're going to show how we derive that formula from special case to more general case. And I think this is much more important to understand how we derive the formula than memorize the formula itself. Of course, the formula itself is very important as well. To derive the triangle area formula, let's start with the area formula for rectangle first. Given a rectangle, the definition of rectangle is you have a quadrilateral with all the four angles as right angle. Okay. For this rectangle, let's say the two sides are A and B. So A unit of one side and B units of another side. And if A and B are integers, we know that just by counting the number of cells, we know the area of this rectangle equals A times B. And the unit of that is the unit square. So if this side length is A centimeter, this side length B centimeter, then the area equals A times B centimeters square. So for this rectangle, the area equals A times B. And now let's look at for a triangle. First, let's consider a right angle triangle. So a right angle triangle is a triangle with one angle 90 degrees, or right angle. And for a right angle triangle, the three sides have its names. The two sides of a right angle triangle is called the two legs. And let's call the two legs the length A unit and B units. And the hypotenuse, this side corresponding to the right angle, is called the hypotenuse. And usually people using a C. But for this purpose, we're not going to use the hypotenuse. So what's this area of a right angle triangle? This is the first triangle, the special triangle we're going to consider. Now, to derive the area of this right angle triangle, we're going to turn this right angle triangle around and rotate it to rotate the same right angle triangle to combine with the original one. So this is another exactly same thing. This is A and this is B. And this makes a right angle, this makes a rectangle. So for this rectangle, from this rectangle area, we know that the whole area of this rectangle equals A times B unit squares. So for this right angle triangle area, you see that it can be half of this rectangle, so A times B divided by 2. So here we got, for this special triangle, a right angle triangle, we know the area equals the product of the two legs and divided by 2. And the reason of that is because this right angle triangle is just half of this rectangle. Now let's generalize this triangle a little bit. Let's consider an acute triangle. Triangle goes like this. One side base is B. And in here, we're going to consider the height corresponding to this base B and call it H. Why we consider this height? It will be very clear after this discussion. And how you draw this height, or actually it's also known as the altitude for this base. You basically start from the vertex corresponding to this base, like opposite to this base, and draw a line perpendicular to this base. So make a right angle line. And the height is the distance or the length from this vertex to the base. This length is called h. And what's this formula for a acute triangle? The area is going to be equals base times height divided by 2. Let's see how we derive that. To derive it, I'm going to show two ways. First, the first method is very intuitive, does not require any algebra. So we use the fact that from this right angle triangle, we see from here, for this right angle triangle, this thing, this is half of this rectangle. And this is half of this rectangle. So for this triangle, it's going to be half of this big rectangle. Correct? So now for this big rectangle, the area equals b times h, because h is the height, so the height makes this a rectangle. This is h, b times h, and this is the area of the rectangle. So the triangle equals half of this rectangle equals half times b times h. The second method builds upon this right angle triangle formula and uses a little bit of algebra. So let's see. Again, consider this right angle triangle here. Let's call this side as x. This leg of this right angle triangle is x. And this side is y. So first, this area of this is going to be, the first area equals h times x divided by 2 because of the formula for right angle triangle, plus on this side is be y, h times y divided by 2. And if you add them up, that's the area for the original acute triangle. And this, now we're using the opposite of distributive law. We can take half h out and makes x plus y inside. But x plus y is just equals b. So that's equals half of h times b. So we know that for the acute triangle, the area formula equals base times height divided by 2. One thing I need to point out is this base is just any base. You can use any of the three sides as a base. So you can use this base, b. Now you have to use its corresponding height, this h. If you're using this base, let's call this as a, then you have to use the height for that base. But you have to draw the altitude. Or you can use the c as the base, and then you have to draw the corresponding height for the c. And which one you want to use as a base and its corresponding height, that depends on the problem. Now, so far we covered the right angle triangle. The area equals the product of the two legs divided by 2. When it's acute triangle, we need to use a base, and then we find the height, and then the area equals base times height divided by 2. Of course, this formula, right angle formula, is just a special case of this acute triangle formula because the a is really the height if you consider b as the base, correct? So the last case we need to cover is, it's not an acute triangle, it's not a right angle triangle, it's an obtuse triangle. In this obtuse triangle, it's called the base, it's still b, and the height is h. Notice that now the height is actually outside of this triangle. So what's the formula for this obtuse triangle? Again, you probably have guessed it out. The area is also going to be equal to b times h divided by 2. How we show that? Think a little bit. I hope you can figure it out yourself. Assume that you have spent some time trying to figure it out. Let's see. I'm going to show, again, two methods, both briefly, because this is very similar to the acute triangle case. The trick is, again, consider the two right-angled triangles in this figure. The first one is this right-angled triangle. The second one is this right-angled triangle. The original triangle's area equals the difference between the bigger one and the smaller one. Now the bigger one, of course, is just half of the area of this rectangle. So the area equals half of the big one, and the smaller one is half of this rectangle. The difference between the big rectangle and the small rectangle is this rectangle, and which has the two sides b and h. So the area equals half of b times h. Alternatively, we can also use the right-angle triangle formula and a little bit of algebra to get it. Let's assume this side is y. I'll call it x. Okay. So for the big right-angle triangle, the area equals b plus x times h divided by 2 and minus x times h divided by 2, because the smaller right-angle triangle has the two legs x and h. So that would be the area for the acute triangle, and equals b plus x times h divided by 2 minus xh divided by 2. And again, we use a trick, distributive law, the opposite of distributive law. Take the common factor out. B plus x minus x, this equals half of h times b. So all the three cases, right-angle triangle, acute triangle, area of a obtuse triangle, the formula equals b times h divided by 2. Taking a base, taking a height, the product of base times height divided by 2. And this is the formula for the triangle area.